This video is on integration using residues. In today's video, we are going to find the residue of the function f of z is equal to 1 by z into e power z minus 1. Clearly, from the question, it is given that f of z is equal to 1 by z times of this is e power z minus 1. So, if you equate the denominator to 0, we are going to get the poles. So, that is z into e power z minus 1 is equal to 0. So, if z is equal to 0 and this one e power z minus 1 to 0, clearly z is equal to 0 is a simple pole and here e power z is equal to 1. So, e power z can be written as this is cos 2 pi plus this one is I sin 2 pi. In general, I am writing this as e power z is equal to cos 2n pi plus I sin, this is 2n pi, where the n value runs from 0 plus or minus 1 plus or minus 2 and so on. So cos theta plus I sin theta can be written as e power I theta. So this is e power z is equal to e power, this is 2n pi I. So here the bases are equal. I am equating the powers, that is z is equal to 2n pi I. So this is one pole and this z is equal to 0 is another pole. And let's get started to find the residue of the function. So here what is the function given? So f of z is given as 1 by z into this is e power z minus 1. So f of z is given as 1 by z into e power z minus 1. For this, so we have to find the residue. For finding the residue e power z, so this can be written as 1 by this value is z into, so e power z can be written as 1 plus this is z by 1 factorial plus clearly z square by 2 factorial plus this is z cube by 3 factorial plus and so on, and last thing is minus 1. Clearly, I can cancel this plus 1 and minus 1. And the next step here is f of z is equal to, this is 1 by z times of, this is z by 1 factorial plus z square by 2 factorial plus z cube by 3 factorial plus and so on. Clear? And now, I am going to multiply with z. I am taking z inside. So this will become f of z is equal to, so f of z is equal to, this is 1 by, this is z square by 1 factorial plus this value is z cube by 2 factorial plus z power 4 by 3 factorial plus and so on. Clear? And therefore f of z is equal to, see here f of z is equal to 1 by, if I take z square common, this will be 1 plus this is z by 2 factorial. If I take z square outside, so this will be z square by 3 factorial plus and so on. Clear? And the next step here is f of z is equal to, see here f of z is equal to, this is 1 by z square. And clearly, if I take this to the numerator, this will be 1 plus this is z by 2 factorial plus z square by 3 factorial plus and so on. Whole inverse. So as you know that 1 plus x, so 1 plus x inverse can be written as 1 minus x plus x square minus and so on. So if I expand in that kind, see f of z value will become, so f of z is equal to, this is 1 by z square into this is the whole thing I am considering this as x, 1 minus this is z by 2 factorial plus z square by 3 factorial plus and so on plus this is again z by 2 factorial plus z square by 3 factorial plus and so on whole square plus and so on. So this is plus and so on. And therefore, see here, this is f of z is equal to, this value is 1 by z square into, this is 1 by, see here, I am writing z by 2 factorial. And if I take z square common, see here, if I take z square common, this will be minus 1 by 3 factorial, and here z square is nothing but whole square. So if I consider z square, this will be plus 1 by 2 square, which is equal to 4. and so on. So this is and so on. And therefore, this can be written as f of z is equal to, this is 1 by z square into 1 minus z by 2 factorial plus z square into 1 by 3 factorial is nothing but 6 plus 1 by 4 plus and so on. So here f of z is equal to 1 by z square into, this is 1 minus z by 2 factorial plus z square into, if I take 12 as LCM, this will be minus 2, and in 4 it comes in 3 times. Therefore, f of z is equal to 1 by z square into 1 minus z by 2 factorial plus 3 minus 2 is nothing but 1. So this will be z square by 12 plus and so on. Now if I set z square inside, so this will be f of z is equal to 1 by z square minus z by 2 factorial into z square plus z square by 12 into z square plus and so on. So if I cancel this one, so if I cancel this for one time, see our f of z value is equal to, this is 1 by z square minus 1 by, this is 2z plus this is 1 by 12 and so on. So here the residue of, so here the residue of f of z is nothing but the quotient of 1 by z. See here, what is the quotient of 1 by z? So the 1 by z quotient is nothing but, so this is 1 by z and the quotient is nothing but minus half. So this is our residue value at point z is equal to 0. So the residue value of the function, at z is equal to 0 is nothing but minus half. So this is how we have to find out. This is also very, very important. And let me explain you for one time. That is, f of z is given as 1 by z into e power z minus 1. So here if you equate the denominator to 0, so these are the simple poles. At the pole z is equal to 0, so we are going to find the residue value. See here, e power z can be written as 1 plus z by 1 factorial plus z square by 2 factorial plus z cube by 3 factorial plus and so on minus 1. So if I cancel minus and plus, and if I send z inside, and after sending z inside and after taking z square common, so this is of the form 1 plus x whole inverse. So 1 plus x whole inverse can be written as 1 minus x plus x square. So if I expand this one and if I take z and z square common, so after taking z square common, if I send z square inside and see, our quotient of 1 by z will be the residue of the function. Therefore, the residue of f of z is equal to the quotient of 1 by z, which is equal to minus half. So this is how we have to solve. These are so many types of problems for solving the residues and the poles. Every video is uploaded. Please go through all the videos and you will be able to solve each and every problem of the residue and finding poles. Thank you so much for watching. If you really understand, please pass it on to your friends, subscribe to this channel and stay connected.